Hello students! Today we're going to look at multiplying and dividing fractions. When we looked at integers and decimals, we started with addition and subtraction and then moved on to multiplication and division. But with fractions, it's easier to start with multiplying and dividing and then move on to adding and subtracting. So today we're going to look at multiplying and dividing fractions. We're going to start with multiplying them, and we're going to just jump in and do a few examples. Let's look at 3/4 times 5/7. The rule for multiplying fractions is pretty straightforward. We multiply straight across in the numerators and the denominators. So in the numerator, we multiply 3 times 5, and in the denominator, we multiply 4 times 7. 3 times 5 is 15, and 4 times 7 is 28. That fraction doesn't reduce, and so we end up with 15/28 as our final answer. Really, all we're doing is multiplying straight across. Let's look at another example. Let's take a look at 3/5 times 2/9. Again, we're going to multiply across. 3 times 2 is 6, and 5 times 9 is 45. In this case, though, we end up with a fraction that can be reduced. 6 and 45 are both multiples of 3, so we can divide the top and bottom by 3. 6 divided by 3 gives us 2. 45 divided by 3 gives us 15, and so we end up with 2/15 as our final answer. We're going to do one more together, and we're actually going to look at it in a couple of different ways. Let's take a look at 3/4 times 8/9. Now, we can multiply straight across just like we did before. 3 times 8 is 24, 4 times 9 is 36, and then we can reduce. Both of these are multiples of 3, so we can reduce by a factor of 3. 24 divided by 3 is 8, 36 divided by 3 is 12. And then we can reduce by a factor of 4, because 8 and 12 are both multiples of 4. 8 divided by 4 is 2, 12 divided by 4 is 3, and we get 2/3. But there's another way of doing this problem. I'm going to rewrite it, 3/4 times 8/9. Instead of multiplying everything first and then canceling in the end, we can do something called cross-canceling to make things simpler earlier on. Let's take a look at the 3 in the numerator and the 9 in the denominator. Both of those are divisible by 3, and when we did the problem earlier, we reduced by a factor of 3 up here, between 24/36 and 8/12. So what we can actually do, because the top and bottom share a factor of 3, we can get rid of that right away. If we look at the 3 and the 9, we can reduce those by a factor of 3. 3 divided by 3 is 1, 9 divided by 3 is 3. And then we can also do something similar with the 8 and the 4. The 8 and the 4 are both divisible by 4, so we can reduce those by a factor of 4. 8 divided by 4 is 2, 4 divided by 4 is 1. And once we've reduced, we can multiply across. 1 times 2 is 2. 1 times 3 is 3, and we end up getting the same final answer of 2/3 without going through the trouble of multiplying to get those larger numbers. We can cross-cancel whenever one of the numbers in the top has the same factor as one of the numbers in the bottom. We can't cancel something that is common between both of the denominators or both of the numerators. It's got to be one numerator that is canceling with one denominator. All right, that is multiplication. Let's take a look at dividing fractions. Let's look at 3/4 divided by 5/7. When we're dividing fractions, there's a really easy step here to change it from a division to a multiplication. If we want to take a fraction division problem and change it to a multiplication problem, all we need to do is flip the second fraction. So instead of 5/7, it becomes 7/5. We call that the reciprocal of the original fraction. When you flip it, it becomes its reciprocal. We can flip that second fraction and change it into a multiplication, and we know how to multiply fractions. We do it straight across. So 3 times 7 is 21, 4 times 5 is 20, and we end up with our answer 21/20. Let's look at a couple more examples. Let's take a look at -5/16 divided by 25/8. Again, we have a division problem, and we can change it to a multiplication by taking the reciprocal of the second fraction. So that 25/8 becomes 8/25. And we know that a negative times a positive is a negative, so we're going to end up with a negative in the end. But let's cross-cancel, because I really don't want to have to multiply 16 times 25. It's a big number. 5 and 25 have something in common. They're both divisible by 5. If we reduce by a factor of 5, we're left with 1 and 5. 8 and 16 also have a common factor. They're both divisible by 8. So if we reduce by 8, we're left with 1 and 2. So our answer, which we said is going to be negative, will have 1 in the numerator. 1 times 1 is 1. And 10 in the denominator. 2 times 5 is 10. And so we end up with -1/10. All right, let's do one more. Let's take a look at -2/7 divided by 5. Here we have an example where one of the two things is not a fraction. We've got 5, which is an integer. However, we can turn any integer into a fraction by putting it over 1, because dividing something by 1 doesn't change its value. So if we replace that 5 with 5 over 1, we now have a fraction division problem, and we can evaluate it by changing it to a multiplication. So this becomes -2/7 times 1/5, because we have to take the reciprocal of the second fraction. When we multiply, we end up with a negative answer, because we've got a negative times a positive. In the numerator, when we multiply, 2 times 1 is 2. In the denominator, 7 times 5 is 35. And we end up with -2/35, which is our final answer. When we are dealing with division, we are allowed to cross-cancel, but it's important that you don't cross-cancel until you've changed it to a multiplication problem. Let's actually do one more to demonstrate that point. Let's take a look at -3/4 divided by -7/12. All right. Now, first of all, we know that a negative divided by a negative is going to be a positive, so we can ignore those negative signs. They're going to cancel. Now, at this point, we can't cross-cancel. You might notice there's a 3 in the top and a 12 in the bottom, but those aren't going to cancel because when we change it to a multiplication, we end up with -3/4 times -12/7. In the multiplication version, the 3 and the 12 are both in the numerator. We know with multiplication, we've got to cancel something in the numerator with something in the denominator. And there is something that we can cancel here. If you look at the 12 and the 4, both of those are multiples of 4. If we reduce by a factor of 4, that leaves us with 3 and 1. And then when we multiply, we've got 3 times 3 is 9 in the top, 1 times 7 is 7 in the bottom, and a negative times a negative is a positive, so we're left with +9/7. If you want to see more worked out examples so you can get a little bit more used to this, click on the link below and watch some of those videos.